Cybersecurity analysts are often taking actions that they expect to increase security of their system. However, sometimes more information is obtained later and the actions need to be reversed. For example, a URL may be deemed malicious, but with more information is later found harmless. In this video, we'll explore how the inverse of these actions can be performed. The focus was driven by the assumption that standards-based information sharing would be used, STIX2 and TAXII2 mainly, and by several questions. First, could we design workflows that combine desired effects from response actions with a native inverse capability for the purposes of reducing risk? And second, could we automate taking action on standards-based revocation messages and tie those actions to the inverse of the forward response actions? The workflow begins by subscribing to a STIX feed and ingesting indicators into an instance of Splunk. The indicators specify different types. Those types are IP addresses, URLs, domains, email addresses, and MD5 hashes. Each indicator also contains the pattern to be blocked. Splunk parses the necessary fields in each indicator and sends that information to the orchestrator, Demisto. Demisto accepts each indicator as an incident and runs a playbook for each based on the type of incident. The playbooks will instruct the necessary appliances to block the associated patterns. Several different appliances and applications are utilized to handle the different types of indicators. The first application used is Microsoft Exchange Server. Microsoft Exchange Server is an email server that allows filtering of emails based on sender via its sender filter agent. Demisto instructs the Exchange Server to add the malicious email addresses to its blocked senders list, thereby blocking emails from those email addresses. The next appliance is Carbon Black Response. Carbon Black Response is one of several components in the Carbon Black Endpoint security suite. Carbon Black Response is an incident response tool that performs unfiltered data collection from the endpoint for the operating system, network, system, and binary information for threat analysis and real-time response. Carbon Black responses used to block MD5 hashes of malicious files. Demisto adds the hash from the indicator to the Carbon Black response database. As you can see, as more indicators come in, the list of banned hashes grows. The final appliance used for blocking is Palo Alto Network Firewall. The PAN firewall identifies all network traffic based on applications, users, content, and devices, and allows users to express business policies in the form of security rules. This workflow uses PAN firewall to block malicious IP addresses, URLs, and domains. Demisto uses a RESTful API to orchestrate actions in PAN. Post requests are sent to PAN that post to specific policies depending on the type of indicator. As stated previously, it's possible that some of these patterns may be declared non-harmful in the future. The workflow for revoking an indicator is similar to blocking. The STIX indicator is passed through Splunk to Demisto, and the same playbook is run corresponding to the indicator type. However, a different branch of the playbook is followed to revoke the indicator. Let's look at this in our three appliances. In Microsoft Exchange, the email address j.smith@gmail.com is in the list, but is removed once the revoke indicator is processed. In Carbon Black Response, we can see the hash beginning with 4EB18 in the banned hashes section. When the revoked indicator containing the same pattern is sent, the hash has moved to the previously banned section. In the Palo Alto firewall, a similar process occurs, but this time we'll try to ping the IP address coming in. We're able to ping the box until the IP address is blocked. The ICMP packet is blocked by the PAN firewall, causing the ping to time out. Once the IP is removed from the list, the ping succeeds again. We can see a similar process with the URL filter in PAN. Here, we see that we can load the IACD website. However, when an indicator is sent containing this URL as the payload, we see that the site is blocked. PAN has that pattern in its URL filter, causing this block to occur. Just like with IP addresses, when the pattern is revoked and removed from the URL filter, users will be able to access the IACD website again. Several important findings were made during this effort. Implementing an inverse workflow is unlikely to be solely reversing the prior workflow. Instead, it usually entails creating a separate workflow to perform the inverse of the first, and this could create barriers in terms of scaling to larger workflows. Also, only courses of action that are designed in a deliberate and careful manner can be properly inverted, and will often require more actions to perform a successful inverse. This concludes the demonstration of running inverse actions in an automated enterprise. Thank you for watching.